guys, that's me again, this time to tell you about the last of the wave properties, diffraction. Okay, so waves can reflect, refract and diffract. I will also tell you about other stuff about waves, but let's just finish off this first. So diffraction. So have you noticed that sometimes you can hear the teacher in a corridor or hear the school band even through you are not inside that room, so a door is open and you can hear what is going on. So this is diffraction, for example. So let's see in more detail. Diffraction happens when waves spread out after passing through a small gap. The closer the gap to the wavelength of the wave, the greater the diffraction, okay? Diffraction is the reason why you can hear a sound in the shadow of buildings, or that you can get radio signals to be heard in the shadows of hills. So how exactly this happens? This animation is from footprints. I don't know how to do these animations. So you have a wave, okay, and the wave, depending on the wavelength, is going to see this space in here to be a gap or not, okay? So if the wavelength of the wave is about the same size as the distance in between these two walls per se, so the distance of this gap, then the wave is going to diffract. If the wavelength is much smaller, it does not see this as a gap at all, so it just carries through without spreading out. However, if this is viewed as a gap, then the wave is going to diffract. So after passing through the gap, the waves kind of spread out. And the way that I like to explain this to people is also, again, imagine that everyone is trying to leave a certain classroom, so lots of students, and they have a door that is not large enough for all the 28 students, for example, to leave the classroom. They kind of squeeze, and then what happens as you leave the classroom, you just don't go straight. You actually, some people go a little bit more to one side, to the other side. So people spread because they want to pass through the door as soon as possible. So as soon as they know that they can leave, they don't wait until carrying on through, just straight forward. They kind of spread out. That's diffraction. If you happen to have a smaller gap, diffraction happens even more. So if the gap is around the same size of the wavelength, then the diffraction happens even more, and the spreading out is even more easily seen, okay? Again, if you have something that the wavelength is too small, they are not going to see that as a gap, so they will just pass through. So that is diffraction. So now let's see some effects of diffraction. I tend to do this as a demo, but you can try at home. So light and sound are both waves, and waves travel in straight lines. So when you are in a room, why can you hear people in a corridor or in another room even though you cannot see them? So get someone in the corridor talking to you. You will listen to them through an open door, but you will not see them. And this is, again, diffraction. Both light and sound are waves, so why is it working with sound and not with light? Well, the answer is very simple. The light waves have a very short wavelength. The wavelength of light is in the order of nanometers, and the sound waves are not diffracted in the sound waves, and the light waves are not diffracted by the doorway. So here should be light waves. I don't know why I wrote sound waves. On the other hand, sound waves have a wavelength that is similar to the width of the doorway, so the gap of the doorway, and diffraction occurs. So this is why you can hear someone in a corridor even though you don't see them. And that is it for diffraction. So I hope it made sense, and up to my next video, be happy and healthy. Bye!